A very good morning to all of you listeners, and good day to all of you listeners around the world as well. My name is Chetan Konaki. I'm the CTO and founder of ShiftLeft. The topic of today is inserting security into DevOps pipeline. So let me start by setting a certain precedent. A greater number of business processes have moved to web-based technologies. These web-based technologies are powered by applications that our engineers write. These applications are often developed quickly with little thought to security. Such applications are fraught with vulnerabilities, a fair number of which are as a result of complexity and the velocity at which these applications are built. So as stewards of enterprise, it is upon us to find all security holes in our applications and portals, while an adversarial entity or an hacker has to only find one. Adversaries are expanding their capabilities every day. What are we doing? Every day we wake up to a new headline, the most recent one being Marriott and Kay Jewelers, which is a data breach as a consequence of a vulnerability being exploited. So let us deconstruct and understand this term strategic asymmetry. The term asymmetric refers to an unequal balance, or when thinking about threats, an unfair advantage exists to the attacker, adversary, or the perpetrator. With today's asymmetric advanced persistent threats, conventional cybersecurity strategies are falling short. Attacks of this nature are undetectable, and once occurred, impossible to determine its origin. So let us draw this parallel between defenders, the role that we play as stewards and enterprises writing software, and attackers who are taking advantage of vulnerabilities that exist in the software that we write. Our approach to contemporary threats is a defense in depth approach, essentially combining various layers like perimeter security, application firewall, conducting static analysis in the early phases of software development lifecycle, conducting dynamic testing as we deploy our solutions in pre-prods or staging environment, and thereafter protecting our workloads by subscribing or procuring RASP solutions or runtime application security solutions, along with advanced or next generation web application firewalls. Thereafter, on a quarterly basis, we do conduct penetration testing as well, just to ensure that the security posture of our application is maintained. Despite of the fact that we are procuring these several tools, integrating them into our software development life cycles, yet attackers are playing into this asymmetric conflict. They are bypassing these defenses. They are undermining our strengths by exploiting our weakest links and using methods that are non-traditional and significantly differ, despite of the fact that we subscribe to a defense in depth approach. So let us start by examining the application. Because we write applications, these applications are deployed in a physical host, a virtual machine, and of late, Docker and as Lambda services. Attacking these applications is a classic case of manipulating strategic asymmetry, because after all, applications are servicing our customers and also providing a front door for attackers. And these applications are in essence portals directly to sensitive data and unknowingly to the soft belly of host and the internal network. We spoke of the two aspects that lead to the fact that our applications are fraught with vulnerabilities. Let us deconstruct both these aspects. The first aspect is velocity. With the advent of DevOps, we deploy software at a velocity which is more than once a day, a week, or perhaps a month. Very mature organizations like Netflix and Facebook are literally deploying multiple times a day. By virtue of this automation that enables faster release cycles, often security gets left behind. The second aspect is complexity. Our applications today are the target du jour because our applications no longer are just code that our engineers write. The fabric is a composition of code that our engineers write, along with open source libraries that they use and frameworks that they deploy the entire fabric upon. With this composition, there's the notion of vulnerabilities by association, meaning that if there exist inherent vulnerabilities in either the open source libraries, the frameworks, or perhaps the third-party APIs that our code utilizes, then the application in itself becomes vulnerable. The third aspect is we are progressively moving towards deconstructing one large monolithic application into multitude of microservices. Now, as these microservices work in concert with each other to serve business workflow needs, data is being handed or passed between these services. Now, if this data is not treated effectively from the perspective of various regulations or compliance bodies, this would lead to data breach or compliance violations. The security of a system is often defined by 4 dimensions. The first dimension is vulnerabilities. These vulnerabilities are defects or weaknesses in the system that can be exercised by an adversarial entity. The attacker or threat is a directed action against a system interface, which is an application. And the goal of the attack is to infringe at least one policy and violate the integrity of our application in order to exploit the vulnerability. The third dimension is policies. Policies guarantee that the system can still give despite attacks, meaning that you define certain rules or constraints based on confidentiality, integrity, and availability. And every request or every action is evaluated against a certain policy. Then comes defenses. When these policies are enforced, there is affirmative action associated with a violation of a policy, meaning we continuously monitor for requests, and if any request is attempting to exploit the application, we detect and then take affirmative action, which could essentially mean block that particular request. The current approach of defense in depth security is to procure various tool sets and integrate them into your software development lifecycle. Your software development lifecycle, albeit agile or waterfall, is comprised of developing software, checking in software into source code management systems, thereafter building that software to create the package artifact, deploying that package artifact into your test or harness environment, conducting acceptance tests, and then thereafter deploying it to production. So at the development phase, we start by procuring SAST tools or static analysis tools, along with software composition analysis tools in order to check the open source libraries for existential vulnerabilities. Now, any results produced by these tools are fed to SIEMs, and they manifest as alerts, which our engineers need to act upon preemptively to address or fix. Now, based on these alerts, the decision to deploy into testing is taken. After it's deployed into pre-prod or acceptance testing environment, we procure a different set of tools. And some of them are DAST or Dynamic Application Software Testing, or IAST, which is Integrated Application Software Security Testing. Now, these tools are reacting to test scripts subjected to your application and observing to identify if any vulnerabilities are being triggered as a consequence. Again, these tools produce alerts. These alerts are fed to your SIEM, and there is some degree of a correlation engine that trickles up or identifies priorities and dispatches those alerts to engineers to address. Thereafter, again, the consequence of the test influences the next step, which is deploying to production. After we deploy to production, we subscribe to tools like RASP, which is Runtime Application Security Protection, and WAF, which is Web Application Firewall. These products are observing for threats and identifying any patterns that would potentially trigger a vulnerability in your system. If a threat exhibits those patterns, an alert is generated. Again, those alerts are dispatched to a SIEM. Note that all these alerts from various subsystems, when dispatched to the SIEM, generates a ton of alerts, more or less what we call as alert fatigue. And despite of the fact that we procure all these tools, yet we wake up every morning to new headlines. Headlines are like what you see on this slide. This is exponentially growing over time. And there is a fundamental reason as to why these tools are rendering themselves to be ineffective. Let us deconstruct why. First of all, there are too many systems to maintain, leading to alert fatigue. And each of these systems are different instruments measuring the same artifact, which is your application. So sometimes static code analysis generates way too many false positives. And it's upon the onus of a human to distill false positives, filter them out, and then identify what are the issues that need to be triaged or addressed. Now, when all these systems in different phases are creating alerts, there is a lacking of context, primarily because these systems are disconnected. And it is the onus of the SIEM and its correlation engine to connect all the data produced or alerts produced by these systems to provide enough data to prioritize which vulnerabilities need to be addressed. And more often, these tools are procured mostly to meet compliance standard needs, not because the intention is to improve the security posture. So let us examine a new approach to connect all these disparate systems together and help an engineer triage and identify vulnerabilities with evidence and proof of exploit and associated priorities. For every release of the software created, it is critical to identify vulnerabilities at high precision in minutes. Because if a typical DevOps deployment pipeline comprises of moving, compiling, and deploying to production in minutes, we cannot be running static scans for hours. The second part is having the capability of taking and analyzing those insights created by these engines and creating an attack surface or auto-creating an attack surface of the application. Because in the next step, which is during acceptance tests and pre-prod, this attack surface can be used by your red team to conduct targeted attacks on your application in order to validate those vulnerabilities. Note, conducting targeted attacks helps in prioritizing vulnerabilities. The following step is to create a security profile based on the attack surface. This profile informs every next subsequent step of what are the weaknesses or the inherent weaknesses in your application that needs extra attention. Now, after we deploy our application in production, we only observe areas of the application that might be vulnerable, and then further observe any threat is applied to exploit these weaknesses. Note the stark difference between what we saw earlier And in this recommended approach is all these systems are connected and there is context behind the connection. Given that they're connected, we can effectively correlate threats to vulnerabilities. And on that basis, we can auto-prioritize vulnerabilities based on the exploits applied. Auto-prioritization would help engineers to remediate and address what needs to be addressed or what matters, given that engineers are focused on time to market and delivering features, not sifting through false positives. So we at ShiftLeft have built such a system that essentially connects your code analysis to your runtime protection and helps prioritize vulnerabilities. And this is done in a continuous loop without compromising DevOps velocity. I'm going to quickly demonstrate the entire process to you to give you a sense of how easy it is to integrate ShiftLeft into your DevOps pipeline and conduct the necessary analysis in minutes. This is an open source project that we have created called as Hello ShiftLeft, which I'm going to use to demonstrate our offering. For sake of demonstration, I'm going to edit one particular file because my GitHub profile is currently connected to Circle CI, which is a continuous integration and automated system that enables compiling any code that I commit and thereafter deploy that code into your public cloud or your private data center. I'm intentionally creating a single edit and committing that edit in order to trigger a build cycle. I quickly shifted to the console of Circle CI to give you a sense of the compilation that is occurring as a consequence of me committing that line of code. ShiftLeft is integrated into this Circle CI pipeline with a simple command, slanalyze. This command takes as input the artifact created as a consequence of the compilation step and then begins the analysis. The analysis constitutes analyzing the jar artifact or the compiled artifact and converting the compiled artifact into a graph. This graph is very similar to a social network graph. Just like Facebook converts connections between humans into a graph, in the same way we convert code into a graph, where functions communicate with each other, thereafter passing variables as a consequence of any request triggered by an input. And thereafter we examine upon the graph for symptoms that could potentially lead to vulnerabilities. Note that this step takes less than 5 to 6 minutes to complete. So I'm quickly shifting to our dashboard, or what you see as a consequence after the analysis is completed. After the analysis is completed, we plot the surface of your application, which is all inbound or input points at which your consumers are interacting with your application and potential adversarial entities are interacting as well. What you also see are vulnerabilities that we have identified in your system or your application. Note that your application, when manifests a business workflow, comprises of inputs like I just described, and also various outbound communication channels as well. Because in order to serve a particular business workflow, we'd have to look up a database or perhaps communicate with a third-party API or another microservice that exists in your microservice mesh. All vulnerabilities that we identify are plotted on these paths because we identify whether at the input you are conducting effective validation or not, and if not, what is the type of vulnerability that can cause any issues on that particular path. I'm going to click into one specific vulnerability, which is an attacker-controlled data dispatched to a database. Note that any alerts that we generate in our dashboard has all guidance and directive to help understand what the vulnerability is, the associated risk of the vulnerability, and necessary guidance and directive to remediate. Particularly, I want to draw your attention to our stack trace. We call this as a security flow trace in our world because we very succinctly describe the points at which a vulnerability can be triggered, the flow path it takes in order to touch a particular resource that that request is interacting with. That resource could be your file system, your database, or another microservice with a network-bound communication. This flow trace or security flow trace gives you sufficient information of how to go about remediating that issue. Meaning if there is lack thereof of validation between the input and the sync point, which could be a database or a file system, then based on the guidance and directive, you can go about fixing it. Allow me to introduce our VP of Product Design, Eitan Lightstone, who is going to walk through in detail our vulnerability dashboard and how to go about processing information using the ShiftLeft product.
Thank you, Chetan. Good morning, everyone. I'm Eitan, and I'll take over the screen share in just a moment. Oh, there we go, show my screen. Okay, thank you for that overview, Chetan, and did a great job just sort of providing the introduction into how we integrate into CI/CD and then getting some of those results in our dashboard. I have an analyzed application that I've prepared right here, and I'll just get to some depth on some of the detail that we can reveal about the security insights that we've picked up. And so one thing I just want to point out is, as I walk you through this experience, consider the fact that the results that we're showing you are both a combination of the code analysis results merged with the runtime analysis that's happening at the same time. So I have a running application with our agent that's pre-configured from that code analysis. So as I step into Hello ShiftLeft, as you can see from the top chart, this is showing overall throughput activity on the application. And I just triggered a few little spikes via some endpoints on this app. And Chetan already gave sort of an overview of what this is revealing. It's effectively showing all data pathways through this application and their relevancy from a security standpoint. And in particular, it's divided into two major sections. On the left, we call these triggers, triggering all data flows on the application. Some of these you can see filled in because I've exercised them in runtime, and some of them have not received any activity as yet. On the right-hand side, we have data destinations, and these are showing categorized sensitive data going out to various destinations like the logging system, back to the web, because this is a web app, and other destinations as well, including database, if this had a database. And one thing I'd like to point out is if I step into one of these categories called payment data, which is seeing runtime activity, and so this might be alarming. That's why we have a red highlight, because this is a violation of policy that payment data should not be sent out to the logging system. So if I drill into this, it effectively filters this whole experience. And if you pay attention to the right-hand side, now what we see here is what looks like Java variables. And so this is one of the interesting ways that our code analysis identifies sensitive data, which is a fairly unique use case solved by a solution like this, where we identify the names of variables semantically or using natural language processing, and we automatically attempt to catalog those. In this case, all are cataloged as payment data. So you see these filters at the top. I'm looking at all data pathways for this application, saving payment data out to the logging system. And I'm going to pick on a variable that I'm interested in, let's say account number. And if I drill into this, This is what Chetan showed earlier, the raw data flow or stack trace, if you will, although it's not exactly the same as like a crash trace. But what this effectively is showing you is how a data flow is initiated, where we identify a sensitive variable, in this case, account number, the various methods that touch that piece of sensitive data. In some cases, it may be transforming it or reassigning it to a different variable name, and then finally sent in as a parameter out to the logging system, which we've identified as a data leak in this case. And so another way that you can consume all this information is, rather than looking at it from this vantage point, which is sort of a data flow overview, we can look at our violations dashboard. And this really highlights, first of all, it's sort of a simple way to get to all the security issues, be they data leaks or traditional vulnerabilities like SQL injection. But one thing I want to point out here is this top histogram, which is showing each analysis that occurred. In other words, each deployment of the application that we've analyzed, and how we've discovered new violations, and how we've identified pre-existing violations that were not fixed from the previous version. And so this dashboard is effectively a high-level overview showing how iterations on this application have either been introducing more vulnerabilities or not, and providing an interface to manage these vulnerabilities, assign them to the right people so that they can get mitigated. But like all things that are visible in the ShiftLeft experience, again, we're blending runtime and code analysis in order to allow you to fully prioritize these issues. So for example, I can prioritize by security events. And now what we're looking at is a sorted list of security issues by severity as well as by security events. In other words, detected incidents happening in runtime for these various problems. And so I can then dig into these, and this is the violation detail or vulnerability detail that Chetan already showed you, and I can start assigning these to people on my team. Of course, there's just me on this particular account. And then we also allow a Jira integration, which I have not enabled on this. So if you don't want to assign internally into the ShiftLeft system, you can of course create a Jira ticket and have individuals on the team take a look at it elsewhere. So let me just return to the dashboard and point out that this is interactive, so I can click back in time and look at historical versions of the application to double check potentially what violations I might have identified in the latest version, and just see whether these exist in these historical versions. And I also have this filter system on the left. So if you have a lot or just want to see a high-level summary of what there is, you can see a quick bar chart here of a summary of violations by type, as well as by other dimensions, like who has assigned violations. Nobody at this point. So if I just assign to myself to quickly demonstrate, there we go. Let me refresh just in case. And if I go to assign to, there we go. We can see that I have one vulnerability assigned to me to go fix. And then I can indicate it as fixed. I think the last point I'd like to make, and I'll return to the dashboard here, is what we've really done here is dug into how you discover these security issues, relating to a single application. But as Chetan has pointed out, microservices architectures are becoming increasingly important and relevant and difficult to handle from a security standpoint. And one of the unique advantages of this approach, first of all, is the seamless CI/CD automation, which of course makes it easier to deploy a security solution like this across multiple services. But in addition to that, we don't have to look at these security results just within one application at a time. We can go look at, first of all, a master list of violations across all applications. And fairly soon we'll be introducing a similar visualization and filter system to this area as well. So you can look at it holistically across your entire architecture. And we're also working on a new type of visualization, the topology view. And if I click on this, this is just a concept at the moment, but it is being worked on right now from an engineering standpoint here, where we can show the relationship between microservices that communicate over APIs, and we can show security overlays on top of that topology. And so this becomes a way to look at kind of the living organism of multiple microservices that are working together and seeing security as an overlay on them. So here I've opened the left panel, which controls the overlay, and I can choose different types of data to see, in this case, medical data passing through one node and to a group node called AWS East in this case. And I can hover over these other ones to see PII passing through almost everything, authentication passing through these three areas out to a database. And so this is a very powerful alternative way to look at these security insights on top of a topology view like this. So we're very excited about this feature coming out. I think I'll conclude the demo here. So Chetan, I'll pass it back to you, and I believe this is where we'll receive any questions. So feel free to type questions, anybody, into the GoToMeeting panel. There's a place to go do that. Chetan, over to you.
Thank you, Eitan. Appreciate it. We have a few questions, so I'm going to read them out loud. The first question is, in data mapping leakage, what happens if you don't detect our variable names? What if we name our critical data foo or bar? Great question. So the ShiftLeft system has bootstrapped data detection, or perhaps sensitive data detection, using terms derived from various compliance and regulatory bodies like GDPR, PCI DSS, SOC 1, Type 1, and Type 2, etc. So using that, we provide value out of the door. But if your organization has specific terms aligned with your business domain, we let you override the policy, meaning you could create your own terms which you deem as sensitive, and then also inherit all the terms that we provide as a consequence of the various compliance and regulation bodies that we have seeded from. The next question: what are the integration points of ShiftLeft in my stack? There are two relatively simple and seamless integration points. Using the same command line tool that we provide, you integrate ShiftLeft into your post-build step in your build server, which could either be a Jenkins, Travis, or Circle CI, or perhaps Team Foundation server. This is a very simple tool. It takes as input the build artifact, and on your premise, it generates this proprietary security graph that we have created. And this graph is securely uploaded into your tenant in our SaaS cloud offering. Thereafter, the same command is inserted in order to instrument a runtime agent into your running application. Note that this is a micro agent, meaning it is informed of only areas that are vulnerable in your application, and using that information, it precisely only observes or instruments those areas, which means that it impacts your application in lower orders, literally in nanoseconds or milliseconds. And its job is to observe only those areas to check if any malicious inputs are applied upon those areas, which is compromising the integrity of your application. If you choose to put us in blocking mode, we will observe, and as we confirm, we will take affirmative action and block that request as well. The next question: will the video recording be available and slides shared? Yes, it will after the meeting. The next question: can this be used to analyze an iOS app? At the moment, we do not support Swift, which is primarily the language used to create iOS apps. As soon as we support Swift, we will inform you of that. The next question: Does this work with IPA files for Apple Store apps? Not at the moment. Given that this question is similar, as soon as we support Swift, we will support the family of iOS apps as well. The next question. So your product looks like a combination of SAST, DAST, and RASP. Is that a fair statement? If I'm already using some DAST or SAST from Fortify, White Hat, do I need to replace them all with ShiftLeft? Or does ShiftLeft work in conjunction with them? Let me answer your question in parts. The first part, does your product looks like a combination of SAST, DAST, and RASP? Of course, yes. It is a combination. It's tightly connected so that all necessary vulnerabilities identified are correlated with threats applied during runtime. The next sub-question was, if I'm already using some SAST or DAST, do I need to replace them, or does ShiftLeft work in conjunction with them? That is your choice, because both hold, meaning that you can deploy ShiftLeft in conjunction with these tools, or you can replace these tools. But we do not integrate with any of these existing tools, meaning we do not take any results generated from an existing tool like White Hat or Fortify and use our protection semantics based on their results. We can run in parallel with those tools, and often certain customers procure more than one tool, but what we advise is to have ShiftLeft so that your administrators do not suffer from alert fatigue. The next question, does it support Node.js applications? Yes, very soon we will be supporting Node.js applications. Please watch out for our announcements on our website, www.shiftleft.io. And as we support, we will keep you informed. The next question, does ShiftLeft integrate with bug tracking tools? Yes, we provide integration hooks with Jira, and it's a one push button integration where you essentially share your access token or auth that you create with Jira, and thereafter all incidents are dispatched to Jira. The next question, where does the name ShiftLeft come from? Great question. The name ShiftLeft comes from essentially the verb moving security to the left. That has been an ambition from a process standpoint with various security stewards and large companies as well. Meaning, how can we detect vulnerabilities preemptively so that vulnerable code is not deployed to production, which essentially leads to exploits. So we derived our name from that verb, ShiftLeft. Do you have a roadmap planned for Node.js applications? Yes, we do. Like I stated, very soon we will release our support for Node.js, and when we do, we will announce it on our website. The next question, my team releases daily. How quickly can you find data leakages? When you integrate ShiftLeft into these two positions, one is in your build server and the other is instrumented along with your running or deployed application, we can detect data leaks in a matter of minutes. We produce a report every time you compile a new release of the same application. And this report would give you a sense of all potential areas of your application where sensitive data is violating compliance constraints. And it also provides necessary guidance for you to go ahead and fix it. By fix, I mean applying necessary obfuscation, encryption, or redaction on those sensitive data elements. And all of this is done in a matter of minutes. This pretty much depends on the complexity of your code. The next question. Who's the typical audience for ShiftLeft? Dev, DevOps, or security? ShiftLeft is a collaborative tool. It provides unit of value to all of these three personas. To devs, because it enables them to prioritize and understand and triage and address vulnerabilities that matter. DevOps, because it seamlessly integrates into the CI/CD pipeline and helps the DevOps personnel take affirmative decision to deploy in staging based on the efficacy of the application from a security standpoint, or perhaps deploy to production or not to deploy, depending on any existence of any high priority vulnerabilities. Security as well, because it provides constant insights into potential threats applied that can exploit vulnerabilities that are inherent in an application. That's it for today. We don't have any more questions. Thank you very much for attending this webinar. And please do visit our website, www.shiftleft.io, particularly the products section, to understand the various product lines and how they integrate with each other to provide unit of value. Also to check out blog.shiftleft.io, where we continuously announce and speak about potential vulnerabilities that we have discovered with our customers and with open source tools that we have processed. Thank you very much and have a good day.